And now we're going to go through our last topic for today, which is to prove, or actually in this case, it's part of our mathematical proof unit, but this is more to disprove something by counterexample, right? So for a mathematical proof, when we need to prove something to be true, whether we do it by exhaustion, by induction, by deduction, we need to prove that it's always true. However, when proving something's false, only one case needs to be false in order to disprove the entire proof. So one single, I'm just going to write it down so we have it as part of our notes. One single counterexample which shows a general statement to be false is enough to disprove the statement. Okay? Okay. So let's just do two examples. Like I said, I think you'll enjoy this one because this one's very close to those situations where we kind of just look at something and we intuitively know that we can either prove or disprove it. Only here, we still unfortunately can't just write in words that it's obviously true, but we can jump straight to a very obvious demonstration. So for the first example, consider the set P of numbers of the form, and I'll have my expression here, of n squared plus 41n plus 41, right? Where n is an element of natural numbers. Now, show that not all elements of P are prime. Okay? And hopefully we don't need the reminder, but if you do, a prime number is just a number that's only divisible by 1 and itself. So, obviously, like perfect examples are like 2, 3, 5, 11, etc. Now, this is obviously not true because if I have multiple scenarios, but the easiest one that comes to mind is if I just have, well, 41, right? So if I plug in n is equal to 41 into my equation, then I'm going to get p is equal to 41 squared plus 41 times, oh my gosh, sorry. It is late and I'm tired, so I'm like speaking one thing and writing another. And I've also misplaced my whiteout. There it is. So 41 times 41 plus 41. Okay, and then here I can factor out a 41 from my entire expression. So then I've got 41 plus 41 plus 41, and this would be 41 times 83, right? And this demonstrates that it's not prime, because now my entire expression p is not only divisible by 1 and whatever the entire expression is, it also has these two factors. So this demonstrates that it's not prime. And because we've demonstrated one scenario to be not true or basically false, then therefore not all elements of P r prime. And that's it. We are done. Like I said, straightforward most of the time. I don't want to make false promises that every single question is transparently true, that you can immediately identify the case for which the statement is untrue, but most of the time it does work that way. So let's do one more example, because then after that, the logic is very straightforward. It's just you're going to get better at it through practice, and that's what the worksheet is for. Okay, so consider the conjecture, and I've got if n is prime, then 2 to the power of n minus 1 is prime, is also prime. Okay, so prove or disprove this conjecture. Okay, now, spoiler alert, because we're currently on our lesson of counterexamples, we're going to disprove this one. So, I'm going to take my case where n is equal to 11, right? Because n is prime in this case, because I've chosen a prime number. But now, when I plug it in, let's see if it stays that way. So now when I plug this in, 2 to the power of 11, and then minus 1, I'm going to get 2047. And this is divisible by 23 and 89. So, not prime. And because one case is not true, therefore the conjecture is false. And we're done. Okay, so just before I end this video, first of all, apologies for any scratchy, messy writing. It is very late and I'm very tired. Um, I've also gotten the news that the trip that I'm one of the two supervisors of for Monday was approved, so we won't actually see each other until Tuesday in class. But other than that, you just have the homework sheet. So you should have gotten a sheet yesterday on the lesson that you did with Miss M. You're going to get two sheets of paper today, one on proof by exhaustion and then counterexamples. So please do that one first, because then the second one are IB questions. So please make sure you have a good handle on all the different types of proofs, and in this case disproofs, that we've covered before you tackle the IB questions. Okay. Um, if you need any help, you're always welcome to email me. My availability over the weekend and when I'm down in the United States on Monday might be might not be reliable. Basically, is what I'm saying. But it never hurts to email me, because worst case scenario, I'll just see it Tuesday morning, and then I'll have it fresh in my mind when I see you in class. Okay. But other than that, I hope you have a great lesson, a great weekend, and I'll see you next week Tuesday.